The morning of August 7th, 1945, Yokosuka Naval Arsenal, Japan. Bay 7. Chief Engineer Takeshi Nakamura stands before a vehicle that shouldn't matter anymore. The war is ending, everyone knows it, even if no one says it aloud. American B-29s have turned entire cities into ash. The Navy is gone, the Army is broken. And here, in this cavernous maintenance bay that once serviced destroyers and cruisers, sits a small, battered American truck, olive-drab paint, chipped and sun-faded, mud caked in the wheel wells, the volcanic black soil of Okinawa still embedded in the treads after weeks in storage. The Americans call it a Jeep. The word sounds almost comical in Japanese jiepu, a strange, borrowed sound for a strange, blunt machine. Nakamura has been avoiding this assignment for 3 weeks. It arrived on July 15th, pulled from the wreckage of Okinawa's final days, one of 3 captured vehicles sent to various military research facilities across what remains of the Japanese Empire. This particular specimen came with documentation, 4,300 miles on its odometer. Manufactured by Willys Overland in Toledo, Ohio, in March of 1943, serial number stamped into the frame, 2045873. His orders are explicit: disassemble it, understand it, document everything. Determine if Japan's military industry missed something, some American engineering principle that explains why these crude little vehicles went everywhere. Japan's carefully designed trucks could not. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Nakamura circles the Jeep slowly, his hands clasped behind his back. At 42 years old, he has spent his entire adult life in pursuit of engineering excellence. Joined Nissan's military division in 1937, part of a generation trained to believe that Japanese precision manufacturing represented the pinnacle of industrial achievement. Every measurement is exact, every tolerance is calculated, every component is a small masterpiece of careful production. He had believed, truly believed, that Japan's military vehicles embodied the warrior spirit through steel and engineering. The Type 94 six-wheel truck, the Type 97 motorcycle, the Type 95 scout car, all products of exacting standards, traditional craftsmanship elevated to industrial scale. And yet, combat reports from the Pacific told a different story. Not the official reports, carefully edited for consumption by the General Staff, but the raw field reports that occasionally made it back to technical bureaus. Reports from exhausted maintenance officers describing vehicles that defeated Japanese logistics through their sheer refusal to break down. Small American trucks that climbed volcanic slopes where Type 94s lost traction. Vehicles that forded rivers, crossed beaches, navigated jungle trails, carried wounded and ammunition, and officers and radio equipment carried the entire weight of America's material superiority on simple leaf springs and 33-inch tires. The impossible part wasn't that these vehicles performed well. The impossible part was that they performed well despite appearing so crude. Nakamura opens the hood. The engine bay is cramped, functional, utterly without aesthetic consideration. He has seen the cutaway technical drawings of German engines, beautiful things, like watch mechanisms enlarged to automotive scale. He has personally overseen the production of Japanese aircraft engines where every component was hand-finished to perfection. This American engine looks like something assembled by farmers, and it works. That's the problem that has kept Nakamura awake for 3 weeks, ever since he received this assignment. That's the question that gnaws at him as he stares at this simple, ugly, effective machine. How does something this crude outperform vehicles built with Japanese precision? His team assembles at 0800 hours, 12 engineers, all veterans of Japan's automotive and military manufacturing sectors. Jun Watanabe, suspension specialist, who designed the intricate independent suspension for several prototype scout cars. Kenji Yamada, just 23, the youngest on the team, fresh from Tokyo Imperial University with a degree in metallurgy. Hiroshi Tanaka, electrical systems. Saburo Ito, transmissions and drivetrains. They are the best Japan has, or had. Gentlemen, Nakamura begins, his voice formal, our task is comprehensive analysis. We will document every component, every design choice, every manufacturing technique. We will understand this vehicle completely. Yamada raises a tentative hand. Sir, if I may ask, what are we hoping to find? Nakamura considers the question carefully. What are they hoping to find? Some secret, some overlooked American innovation? Or are they simply hoping to understand how they lost? We are hoping, Nakamura says slowly, to find the truth. To understand what Nakamura and his team are about to discover, you must first understand what they believed. Japan's military vehicle development in the 1930s and early 40s was guided by a philosophy inherited from European, particularly German, engineering traditions. The emphasis was on quality, precision, and technical sophistication. A Japanese military truck was not merely a tool, it was a product of national character, an expression of the same dedication to perfection that guided samurai sword-making, traditional architecture, and every other craft where Japan had excelled for centuries. The Type 94 six-wheeled truck, introduced in 1934, exemplified this philosophy. Based on German Krupp designs, it featured a powerful inline six-cylinder engine producing 70 horsepower. Its six-wheel configuration provided excellent cross-country performance in theory. The transmission was a marvel of mechanical sophistication, 4 forward speeds with carefully designed synchronizers that made shifting smooth and precise. Production of the Type 94 required approximately 340 hours of labor per vehicle. Each engine was individually assembled by skilled craftsmen. Tolerances were held to 1/10,000th of an inch, the same precision standards used in aircraft engine manufacturing. The result was a vehicle that, when properly maintained, performed beautifully. The problems emerged in combat conditions. The Type 94's complex engine required constant maintenance. Tropical heat in Southeast Asia caused frequent overheating. The sophisticated transmission, while smooth in operation, failed regularly under combat stress. Spare parts had to be manufactured to exacting specifications, making field repairs nearly impossible. Mechanics needed specialized training. The technical manual ran to 473 pages. By 1943, Japanese logistics officers in the Pacific Theater were reporting severe vehicle attrition rates, not from combat damage, but from mechanical failure and inability to repair. A Type 94 that threw a rod in the jungles of New Guinea was effectively lost. No field workshop could produce a replacement cylinder to proper tolerances. Meanwhile, American vehicles multiplied like some mechanical plague. Intelligence reports from captured positions described American supply dumps stacked with spare parts. Not carefully catalogued precision components, but bins of standardized parts, carburetors, alternators, entire engines that mechanics swapped out like children's building blocks. American vehicles were maintained by soldiers who, in peacetime, had been farmhands and factory workers, not trained precision craftsmen. Japanese military doctrine had assumed that technical superiority would compensate for industrial capacity. One Japanese truck, properly designed and maintained, should outperform 3 American vehicles. That was the theory. Reality proved different. By mid-1945, Japan's military vehicle production had collapsed entirely. The factories that had built Type 94s with such care were either destroyed by bombing or starved of raw materials. The Jeep sitting in Bay 7 of Yokosuka Naval Arsenal represented more than just a captured vehicle. It represented the complete failure of Japanese manufacturing philosophy in modern industrial warfare. Nakamura understood this in abstract terms. What he did not yet understand was why. The disassembly begins on August 8, 1945. Standard procedure. Exterior documentation first. Watanabe takes measurements while Yamada records everything in a leather-bound notebook. The Jeep's dimensions are modest 80 inches wheelbase, 132 inches overall. Length, 62 inches wide. Height to the top of the windscreen, 52 inches. Ground clearance, 8 3/4 inches. Weight, 2,453 pounds. Lighter than I expected, Watanabe observes. The Type 97 motorcycle with sidecar weighed nearly as much. The suspension is examined next. Simple leaf springs, front and rear. No independent suspension, no sophisticated shock absorption. The front axle is solid, mounted on springs that look almost agricultural in their simplicity. Watanabe, who has designed complex multi-link independent suspensions, stares at the leaf springs with something approaching confusion. "This is very basic," he says carefully. "Does it work?" Nakamura asks. "According to the combat reports, yes, extremely well. Then perhaps we have been designing the wrong things." The wheels come off next. 5 identical wheels, 4 corners, plus a spare mounted on the rear. 33-inch tires, designed by a company called Goodyear. The wheels themselves are simple stamped steel, painted the same olive drab as the body. No aesthetic consideration whatsoever. They are crude, functional, interchangeable. That word keeps appearing in Yamada's notes. Interchangeable. In Japanese military vehicle design, components were precisely matched. Each wheel was balanced individually. Each tire was inflated to exact specifications. The American approach seemed almost careless by comparison. Any wheel fit any position. The spare was identical to the other 4 in every respect. "Sir," Yamada asks, "why would they make all 5 wheels the same? It adds weight to carry a full-size spare." Nakamura considers this. Simplicity. Any wheel can replace any other wheel. No need to remember which corner of the vehicle it came from. But that's inefficient. Is it? Nakamura gestures at the Jeep. This vehicle crossed the Pacific Ocean, drove through the Battle of Okinawa, and still runs. How many Type 94s can claim the same? Yamada has no answer. August 10th, 1945. The engine extraction. 6 men lift the Willys Go Devil engine from its mounts. It comes out easily, 4 bolts, fuel lines, electrical connections. In under an hour, the engine sits on the examination table. Nakamura's team circles it like surgeons studying a patient. 134 cubic inches of displacement, 4 cylinders, overhead valves, compression ratio of 6.5 to 1, maximum output 60 horsepower at 4,000 revolutions per minute, maximum torque 105 pound-feet at 2,000 revolutions per minute. By Japanese standards, these are modest specifications. The Type 94's engine produced 70 horsepower from a larger displacement. More sophisticated Japanese engines, particularly aircraft engines, produced far more power per cubic inch, but those engines required high-octane fuel, skilled maintenance, and careful operation. This American engine was designed to run on virtually any fuel, be maintained by amateurs, and survive brutal treatment. The first real shock comes when Watanabe measures the cylinder bores. "Sir," he says quietly, "the tolerances." Nakamura examines the measurements himself. The cylinders are machined to tolerances of approximately 1/1000th of an inch. By Japanese standards, this is shockingly loose. Japanese military engines were held to 1/10,000th of an inch, sometimes tighter. "This engine should destroy itself," Watanabe says. "These tolerances are too loose. Thermal expansion alone should cause the pistons to seize." And yet, Nakamura reminds him, 4,300 miles. They disassemble the engine completely over the next 3 days. Every component is measured, weighed, and documented. A pattern emerges not in what the engine does, but in what it doesn't do. It doesn't try to achieve maximum efficiency. The compression ratio is deliberately conservative, reducing stress on components. It doesn't use exotic materials, just cast iron and basic steel alloys. It doesn't require precision assembly. The loose tolerances mean parts can be slightly out of specification and still function. The crankshaft exemplifies this philosophy. In a Japanese aircraft engine, the crankshaft would be forged from special alloy steel, then precision ground and balanced to eliminate even microscopic weight variations. The Jeep's crankshaft is heavier, rougher, balanced only approximately. "This is peasant engineering," Tanaka mutters. Nakamura doesn't respond immediately. He's staring at the crankshaft, turning it over in his hands, and something is crystallizing in his mind, something uncomfortable, something that challenges every assumption he's carried for 20 years. "Kenji," he says to Yamada, "how long do you think it took to manufacture this crankshaft?" Yamada examines it. "This quality? Perhaps 3 hours, maybe less. And a comparable Japanese crankshaft? Minimum 15 hours, sometimes 20, depending on specifications." Nakamura sets the crankshaft down carefully. "So with the same factory capacity, the same number of skilled workers, America can produce 5 crankshafts for every one we make." "Yes, but ours would be superior." "Would they?" Nakamura interrupts. "Superior in what way? This crankshaft has survived thousands of miles of combat conditions. It works. That is the only superiority that matters in war." The room falls silent. The transmission proves equally revelatory. Japanese military trucks used complex gearboxes with synchronized shifting, smooth, refined, requiring careful operation. The Jeep's T84 transmission is almost brutally simple. 3 forward gears, 1 reverse, with a gear reduction transfer case that provides 4-wheel drive. Ito, the transmission specialist, disassembles it with growing bewilderment. "There's no synchronization," he notes. "Shifting must be difficult." "Soldiers were trained to double clutch," Nakamura explains, based on what intelligence reports had documented. "The transmission is designed assuming rough treatment. But why not include synchronizers?" "The technology exists because," Nakamura interrupts, "synchronizers add complexity, more parts that can break, more precision required in manufacturing. The Americans designed for soldiers who might have weeks of training, not years. They were designed for mechanics who learned in field conditions, not specialized schools." Ito lifts the transfer case assembly. It's heavy, simple, and elegant in its directness. A lever allows the driver to select two-wheel drive, four-wheel drive high range, or four-wheel drive low range. No sophistication, no refinement, just mechanical directness. A child could understand this, Ito says. Exactly, Nakamura responds. That's exactly the point. The four-wheel drive system crystallizes everything Nakamura's team has been discovering. Japanese engineers had experimented with four-wheel drive, but found it too complex for mass production. The Jeep solved the problem through aggressive simplification, a transfer case so straightforward that Nakamura sketches its entire mechanism in under 20 minutes. But simplicity wasn't just about ease of understanding. It was about ease of manufacturing, ease of repair, ease of supply chain management. Every simplification multiplied across thousands of vehicles, millions of components, the entire industrial system. August 13th, 1945. Evening. Nakamura sits alone in his office at the arsenal, surrounded by technical drawings and measurement logs. Outside, Yokosuka's dark electricity is rationed now, and even military facilities go unlit after sunset. He spreads the drawings across his desk. Every major system of the Jeep, documented in meticulous detail. Engine, transmission, suspension, frame, electrical, fuel system. Not one system shows technical superiority to Japanese equivalents. Not one. The Jeep's engine is less powerful than comparable Japanese engines. Its transmission is cruder. Its suspension is simpler. Its electrical system is basic. Its construction quality, by Japanese standards, is almost primitive. And yet the Jeep works better. Nakamura thinks about the Type 94 six-wheeled trucks, beautiful machines that required 340 hours to build and broke down in jungle heat. He thinks about Japanese scout cars with sophisticated independent suspension that became helpless when a single component failed and no spare parts were available. He thinks about precision-manufactured engines that seized when tropical grit contaminated oil past microscopic tolerances. The Americans hadn't built better vehicles. They'd built more appropriate vehicles. They're designed for reality, not theory. For average soldiers, not skilled specialists. For combat conditions, not parade grounds. For an industrial system that could produce 1 million vehicles instead of 100 perfect ones. A knock interrupts his thoughts. Yamada enters, holding the leather-bound notebook where he's recorded every measurement, every observation. Sir, I've been thinking about the frame welds. Yes? They're ugly, rough, but I calculated the time required. We estimate 90 seconds per weld. Our vehicles require 4 to 6 minutes per weld. The time savings across an entire vehicle is enormous. Nakamura finishes. I know. Sir, do you think Yamada hesitates? Do you think we've been doing it wrong all this time? It's the question Nakamura has been avoiding for days. The question that strikes at the foundation of everything he's believed about engineering, about craftsmanship, about the Japanese way. We have not been doing it wrong, Nakamura says slowly. We have been answering the wrong question. We asked, how do we build the best truck? The Americans asked, how do we build enough trucks that work well? Enough? Different questions, different answers. But which question is correct? Nakamura looks at the drawings spread across his desk. In war, Kenji, the correct question is always the one that leads to victory. The Americans are winning. That makes their question correct. August 14th, 1945, morning. The team reconvenes for final testing. They have reassembled the Jeep, every component returned to its proper position. Everything documented, measured, understood. We should run it, Watanabe suggests. See how it performs. They have enough fuel for brief testing the arsenal's reserve stocks, carefully hoarded. Nakamura slides behind the wheel. The seat is a flat canvas stretched over a simple frame. No cushioning, no comfort. The controls are basic: clutch, brake, accelerator, gear shift, transfer case lever. He turns the key. The Go Devil engine cranks once, twice, fires to life immediately. Remarkable, after weeks of disassembly. The Arsenal's test track is a loop approximately 1 kilometre long, with obstacles designed to evaluate military vehicle performance. A 60% grade, a water obstacle half a metre deep, a rough terrain section with logs, rocks, simulated battlefield debris. The Type 94 six-wheeled truck had struggled with this course. Complex transmission overheating, sophisticated suspension components damaged by impact, required careful driving and multiple attempts. Nakamura engages four-wheel drive low range and approaches the grade. The Jeep climbs it without hesitation. Engine labouring but never struggling. Simple leaf springs absorb the rough surface, crude but adequate. The water obstacle next. He enters at moderate speed. Water splashes over the hood, over the windscreen. The Jeep pushes through without stalling, without drama. The rough terrain section is the final test. Logs spaced irregularly, forcing severe suspension articulation. Large rocks require ground clearance and precise wheel placement. The course that had damaged multiple Japanese vehicles during testing. Nakamura drives through at steady speed. The Jeep pitches and rolls, suspension working hard, but nothing breaks, nothing fails. The vehicle absorbs punishment that would have fractured Japanese suspension components. He stops at the end of the course and sits in silence. His team has followed on foot. They stand around the Jeep, staring at it with expressions Nakamura cannot quite read. Not admiration that would be too simple, something more complex, recognition perhaps, or grief. It's not better than our vehicles, Nakamura says finally, not in any single measurement. Our trucks are more powerful, our suspensions are more sophisticated, our manufacturing is more precise. Watanabe nods slowly. Then why? Because they designed it to work in war. We designed our vehicles to meet specifications, to embody principles, to represent Japanese craftsmanship. Nakamura's voice is hollow, drained. They are designed for mechanics who are terrified and exhausted, for supply chains that break down, for conditions that cannot be predicted, for the reality of combat, not the theory of it. Yamada speaks quietly. We designed vehicles that require Japan. They designed vehicles that create America anywhere they go. The observation hangs in the humid August air. That evening, Nakamura begins his official report. 37 pages of technical analysis, detailed drawings, precise measurements, material specifications, everything documented according to Japanese military bureaucratic standards. But the conclusion is only 3 sentences long. The American Jeep represents a manufacturing philosophy fundamentally different from our own. They have sacrificed individual component excellence for system-wide reliability and ease of production. We cannot replicate this vehicle without changing our entire approach to engineering and industrial organization. He signed the report at 19/12, 2300 hours on August 14, 1945. Place it in the outgoing document folder for delivery to the Army Technical Bureau in Tokyo the following morning. He did not sleep that night. Sits in his office, staring at the sketches of the Jeep's transfer case mechanism, so simple, so functional, so utterly devastating to everything he'd believed about superior engineering. At 0700 hours on August 15, 1945, the radio broadcast begins. Emperor Hirohito's voice, speaking formally, announcing Japan's acceptance of the Potsdam Declaration. Surrender. The war is over. Nakamura listens to the broadcast standing in Bay 7, next to the reassembled Jeep. Around him, other engineers and arsenal workers listen in stunned silence. Some are crying. Others stand rigid, faces carefully blank. When the broadcast ends, Nakamura walks to his office and retrieves his report from the outgoing folder. There's no point sending it now. No army. Technical bureau will read it. No procurement officers will act on it. The war has ended. He files it in his personal desk drawer instead. The Jeep sits in Bay 7, engine still faintly warm from yesterday's test. Mud from Okinawa is still embedded in its wheel wells, 52 inches tall, 80 inches between axles, 2,453 pounds of American pragmatism. It has already won its war. The Americans arrived at Yokosuka Naval Arsenal on August 28, 1945. They come in jeeps, naturally. A convoy of them, olive-drab vehicles rolling through gates that once serviced the Imperial Japanese Navy's most powerful warships. Nakamura watches from the window of his office as American soldiers, impossibly young, impossibly casual, jump from the vehicles and begin surveying the facility. The occupation has begun. Lieutenant Robert Hayes, United States Army, 24 years old, from Detroit, Michigan, is assigned to document Japanese military equipment and industrial facilities. His background is automotive engineering, worked at Ford before the war, enlisted in 1942, and spent 2 years in the Pacific Theater as a technical intelligence officer. Hayes walks through Yokosuka with a clipboard and a camera, cataloguing everything. Destroyers in dry dock, their hulls rusted and incomplete, machine tools sitting idle for lack of electricity, warehouses filled with parts for aircraft that no longer exist. He entered Bay 7 on September 3, 1945. The disassembled Jeep is still there, components laid out on workbenches with almost surgical precision. Every part is cleaned, measured, and labelled in Japanese characters. Hayes stops, surprised. "Somebody tore down one of ours," he says to his translator, a Nisei soldier from California named James Takahashi. Takahashi speaks to one of the Japanese workers, who quickly fetches Nakamura. The two engineers meet in Bay 7, separated by language, by culture, by the vast chasm of victory and defeat. Hayes is tall by American standards, taller still compared to most Japanese. Nakamura is formal, careful, his English limited but functional. "You examined this vehicle?" Hayes asks through Takahashi. "Yes." Nakamura responds, "Complete analysis, all systems." Hayes looks at the organized components. "Pretty thorough. Learn anything interesting?" Nakamura chooses his words carefully. How does one explain to a victor that his crude vehicle has shattered an entire philosophy of engineering? "We learned," Nakamura says slowly, "that American engineering is not what we expected." Hayes laughs not mockingly, but with genuine amusement. "Yeah, I bet. Our stuff looks pretty rough compared to your work, but it gets the job done, right?" "Yes," Nakamura says quietly, "it gets the job done." Hayes doesn't understand the weight of that admission, cannot understand what it means for a Japanese engineer to acknowledge that crude simplicity defeats careful craftsmanship, cannot know that this moment, in this maintenance bay, represents the death of an entire industrial ideology. "Mind if I take some pictures?" Hayes asks. "For the technical reports." Nakamura gestures for permission. Hayes photographs the disassembled Jeep, the careful layouts, the notebooks filled with measurements and observations. Years later, these photographs will end up in the U.S. Army Military History Institute, filed under Japanese Technical Intelligence Activities, August-September 1945. Occasionally viewed by military historians, never fully understood. Before Hayes leaves, he turns back to Nakamura. "You know, we're going to need guys like you, rebuilding Japan. Got any interest in civilian vehicle production?" Nakamura nods slowly. "Yes, I believe I do. The immediate post-war period is chaos. Japan's industrial base is shattered. The Ministry of Munitions is dissolved. The Army Technical Bureau ceases to exist. Engineers who spent years designing military vehicles suddenly find themselves unemployed, their skills seemingly obsolete in a nation forbidden from maintaining armed forces." Nakamura returned to Nissan in October of 1945. The company's military vehicle division no longer exists, dissolved by occupation authorities. But civilian vehicle production is permitted, even encouraged. Japan needs trucks, buses, and transportation to begin rebuilding. The design meetings in late 1945 and early 1946 are strange affairs. Engineers who never spoke of defeat now must confront it directly. Their vehicles had failed. The entire Japanese approach to automotive engineering had proven inadequate. "We need to start over," Nakamura said in a meeting in January of 1946. "Everything we knew, we must question everything. Resistance comes from older engineers, men who built their careers on precision craftsmanship. Our quality was never the problem," argues Yoshida, a senior transmission designer. "We lost because of industrial capacity, resources, and bombing, not because of engineering philosophy." "Then why," Nakamura asks quietly, "did their crude vehicles outperform our sophisticated ones in every theater of the war?" Silence. "I examined an American Jeep," Nakamura continues, "completely, every component. It was not better than our vehicles in any single measurement. But as a system, as a complete vehicle, it worked better. And do you know why?" He stands, walks to the blackboard, and begins sketching. "They were designed for imperfection, loose tolerances, so parts could be manufactured quickly and replaced easily. Simple mechanisms, so any mechanic could understand them. Robust over-engineering, so components exceeded minimum requirements. They designed for reality, for exhausted mechanics, for damaged supply chains, for conditions that cannot be predicted." Yamada, who has also returned to Nissan, adds, "They designed vehicles that create their own logistics. We designed vehicles that require perfect Japanese logistics to function. The realization settles over the room like ash. But knowledge alone cannot immediately transform an industry. Japan's automotive sector in 1946 faces obstacles that have nothing to do with engineering philosophy. Raw materials are scarce, steel is rationed. The few factories still operating run at a fraction of capacity due to electricity shortages. The occupation authorities control what can be produced and how. Nissan's first post-war civilian truck, introduced in 1947, is essentially a modified pre-war design. Because that's all they can manage, no resources for new development, no capacity for experimentation. The company produces fewer than 2,000 vehicles in 1947, most of them assembled from pre-war parts stocks. But conversations are happening, ideas are spreading, in universities, in design offices, in late-night meetings where engineers drink sake and talk about what went wrong, a consensus emerges. Japanese manufacturing must change. Not abandon quality that would be unthinkable, but redefine what quality means. Not perfection in components, but reliability in systems. Not beautiful engineering, but engineering that works. The philosophical shift happens slowly, then suddenly. In 1948, Nissan engineers began work on a new four-wheel drive vehicle. Not for military use, occupation forces strictly control that, but for civilian applications. Forestry, construction, rural transportation. The project is modest, under-resourced, but it represents something new. Nakamura is not the lead designer. His role is advisory, but his influence permeates the project. The design principles he articulated are everywhere. Simple, proven technologies rather than innovative complexity. Tolerances calculated for reliability rather than precision. Components designed for field, just repair by average mechanics. Standardized parts wherever possible. Robust over-engineering of critical systems. The vehicle that emerges in 1951 is the Nissan Patrol 4W60. It looks nothing like a Jeep, larger, heavier, distinctly Japanese in appearance, but the philosophy underneath is recognizable. The Patrol uses a simple inline six-cylinder engine, powerful, conventional, easy to maintain. Its transmission is straightforward, based on proven truck designs. Suspension is leaf springs front and rear, not sophisticated, but reliable and repairable. The four-wheel drive system is mechanically simple, adapted from earlier designs but refined for ease of use. Most importantly, the Patrol is designed with Japanese manufacturing realities in mind. Parts are standardized where possible, but not at the expense of function. Quality control is rigorous, but focused on system reliability, rather than component perfection. Manufacturing tolerances are appropriate to use case rather than arbitrary precision. The Patrol becomes a success not immediately, not dramatically, but steadily. It works. In forests, on construction sites, in rural areas with minimal maintenance infrastructure, it simply works. The first units reach customers in 1951. By 1955, the Patrol had established itself as a serious four-wheel drive vehicle, and quietly, without fanfare, it vindicates everything Nakamura learned from that disassembled Jeep in Bay 7. The transformation of Japanese automotive engineering accelerated through the 1950s. Toyota introduced the Land Cruiser in 1951 initially for Japanese police and civilian uses, eventually for export. Like the Patrol, it embodies simplified reliability. Its design borrows conceptually from the Jeep while adapting to Japanese needs and manufacturing capabilities. Ironically, in 1953, Mitsubishi began licensed production of the Jeep itself for the Japanese, self-defense forces and civilian markets. The same vehicle, Nakamura disassembled, now manufactured in Japan under license from Willys. Japanese engineers study it again, this time not as a captured enemy vehicle, but as a product to replicate. The lessons deepen. Manufacturing the Jeep under license requires Japanese factories to adopt American production techniques, standardization, interchangeability, efficiency over perfection. The experience transforms Japanese manufacturing culture more profoundly than any theoretical discussion could. By the late 1950s, Japan's automotive industry had internalized the lessons of defeat. Not abandoned quality Japanese vehicles remain well built, but redefined quality in practical rather than abstract terms. Quality means reliability, maintainability, fitness for purpose, not perfection for its own sake. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The real revolution comes in manufacturing processes. Kenji Yamada, the young engineer who noticed the Jeep's crude welds back in August of 1945, joins Toyota in 1952. He rises quickly, becomes involved in production engineering, and begins asking uncomfortable questions about Japanese manufacturing efficiency. Why does Toyota require 300 hours to build a truck when American companies need half that time? Why are Japanese production lines so inflexible? Why do manufacturing processes prioritize perfection over speed? Yamada begins experimenting with concepts that will eventually become the Toyota production system, the manufacturing philosophy that revolutionizes global industry. Just-in-time inventory, continuous improvement, elimination of waste, standardized work, quality built into processes rather than inspected into products. The intellectual lineage traces directly back to that Jeep, to the recognition that American manufacturing succeeded not despite its apparent crudeness, but because of its systematic efficiency. The Americans had built an industrial system optimized for production at scale. Japan had built an industrial system optimized for craftsmanship at small scale. Modern war required the former. Modern peacetime prosperity would require it too. In a 1958 interview with a manufacturing journal, Yamada is asked about the origins of his production philosophy. He doesn't mention the Jeep specifically. The memory is still somewhat painful, wrapped up in defeat and national humiliation. But his answer is revealing. I learned that the best engineering makes the worker's job easier, not harder. That the best manufacturing process is the one that produces reliable products efficiently, not the one that produces perfect products slowly. These lessons came from studying American industry after the war. What he doesn't say, those lessons came from 3 weeks in August of 1945, disassembling an enemy vehicle that shouldn't have been better but was. Takeshi Nakamura continued working at Nissan through the 1950s and 60s, eventually retiring in 1973 at age 60. His colleagues noticed a change in him after the war. The pre-war Nakamura had been exacting, demanding perfection, intolerant of shortcuts. The post-war Nakamura advocates for simplicity, for robustness, for designs that work in imperfect conditions. He never speaks publicly about his assignment at Yokosuka, never writes articles about the Jeep he disassembled, never seeks credit for influencing Japanese automotive design philosophy. In Japan's corporate culture, such self-promotion would be unseemly anyway. The work matters, not the individual, but his influence is everywhere. Engineers who worked under him spread his principles throughout the industry. Design reviews where he asks, "But will this work when the mechanic is exhausted? When spare parts are delayed? When conditions are not ideal?" These questions become standard. The report he wrote, 37 pages, filed in his desk drawer on August 15, 1945, stays with him throughout his career. He never submits it officially, no point, but he rereads it occasionally, this document from another lifetime, when Japan was at war, and a simple American vehicle revealed truths about engineering that tradition had obscured. In 1968, a young Nissan engineer named Suzuki was assigned to Nakamura's team. They're working on the next generation Patrol, updating the design for modern requirements. Suzuki proposes an independent suspension system, more sophisticated, more comfortable, more complex. Nakamura studies the proposal carefully. It will improve ride quality, he acknowledges. But how many more components? How much more difficult to repair in field conditions? Substantially, Suzuki admits. But customers expect refinement now. We're not in wartime. No, Nakamura agrees. But the principle remains. Design for the reality of use, not the ideal. Customers in Australia, in Africa, in rural areas, they need vehicles that work, not vehicles that impress in Tokyo showrooms. The Patrol keeps its solid axles and leaf springs, crude perhaps, but reliable. The vehicle becomes legendary in harsh conditions worldwide: Australian outback, African deserts, South American jungles. It works, just like the Jeep worked. The 1970s witnessed Japan's automotive industry reach parity with, then surpass, American manufacturers in many metrics. Toyota, Nissan, Honda, these companies have become synonymous with reliability, fuel efficiency, and quality. The oil crisis of 1973 accelerates their success. American vehicles, designed for cheap gasoline and domestic tastes, struggle. Japanese vehicles, efficient and reliable, thrive. Ironic, given that 30 years earlier, Japanese engineers were disassembling American vehicles, trying to understand American superiority. But the lessons learned in defeat enabled victory in peace. Japanese manufacturers understood that automotive excellence meant different things in different contexts. In wartime, it meant simplicity and reliability. In peacetime, it meant efficiency and quality. The underlying principle remained: understand the actual use case, design for reality, don't let abstract ideals override practical function. American manufacturers, ironically, forgot some of their own lessons. The companies that built the Jeep, that pioneered mass production and systematic efficiency, became complacent. Quality control slipped. Design became more about aesthetics than function. Manufacturing prioritized short-term cost reduction over long-term reliability. By the 1980s, Japanese vehicles were demonstrably more reliable than American equivalents. Consumer reports, J.D. Power surveys, owner satisfaction ratings all show Japanese brands at the top. The student has become the master. Nakamura, retired now, watches this transformation with complex emotions. Pride in Japanese achievement, satisfaction that the lessons of 1945 bore fruit, but also something else, a kind of melancholy recognition that success brings its own dangers. In a rare interview in 1981, conducted by a Nissan company historian preparing an internal history, Nakamura is asked about the source of Japanese automotive success. "We learned from defeat," he says simply. "We learned that being right about principles but wrong about reality is the same as being completely wrong. We learned to be humble about our assumptions and ruthless about testing them against truth." "And what did you personally learn, sir, during your career?" Nakamura is silent for a long moment. "I learned that in August of 1945, when I examined an American military vehicle, I thought I was studying engineering, but I was actually studying philosophy. The philosophy of how to think about complex problems, how to balance competing demands, how to know what matters and what doesn't." The interviewer asks if he kept any records from that period. Nakamura hesitates, then retrieves the old report from his personal files. 37 pages, yellowed now, filled with measurements and drawings and observations from another lifetime. "This was my real education," Nakamura says, holding the document carefully. "Everything I did afterward, all of it traces back to 3 weeks in 1945, when I learned that my understanding of excellence was incomplete." He returns the report to his files. It will stay there until his death, when his family will donate it, along with other papers, to Japan's Automotive Hall of Fame. Takeshi Nakamura died on March 14, 1983, at age 72, in his home in Yokohama. The obituary in the Nissan company newsletter is brief, respectful, noting his 46 years of service and his contributions to post-war vehicle development. It mentions his work on the Patrol series, his mentorship of younger engineers, his dedication to practical design principles. It does not mention Yokosuka, does not mention August of 1945, does not mention the Jeep. His family, sorting through his personal effects, finds the report. They don't immediately understand its significance, just an old technical document, measurements and drawings, written in the formal style of military bureaucracy from another era, but the care with which it was preserved suggests importance. They donate it, along with other papers, to the Japan Automotive Hall of Fame, where it becomes part of the permanent collection. Filed under Post-War Reconstruction Period, Technical Analysis and Industrial Philosophy. Occasionally, historians studying the transformation of Japanese industry examine it. The document is remarkable for its honesty. Nakamura doesn't make excuses, doesn't blame defeat on circumstances or resources. He simply catalogues what he found. An American vehicle that worked better than Japanese equivalents, despite being cruder, simpler, less refined. And he draws the hard conclusion. Japanese engineering philosophy requires fundamental revision. Reading the report decades later, with full knowledge of how the Japanese automotive industry evolved, the document feels almost prophetic. Everything Nakamura identified in 1945, simplicity, reliability, design for reality, became core principles of Japanese manufacturing success. But more than the specific insights, the report reveals something about how progress happens. Not through comfortable confirmation of existing beliefs, but through uncomfortable confrontation with contradictory evidence. Nakamura could have dismissed the Jeep as crude American workmanship, could have concluded that Japanese vehicles were superior in theory, only defeated by circumstance. Instead, he let reality shatter his assumptions, and in doing so, helped transform an industry. The Jeep itself, the specific vehicle Nakamura examined in Bay 7, disappeared into the chaos of occupation. No records indicate what happened to it. Likely scrapped for metal during the post-war reconstruction period, or perhaps cannibalized for parts to keep other vehicles running, or simply abandoned somewhere, rusting away while history moved forward. It doesn't matter. The physical vehicle was never the point. What mattered was what it represented. A different approach to engineering problems. A different philosophy about what makes a vehicle or any technology successful. A different answer to fundamental questions about quality, reliability, and fitness for purpose. Lieutenant Robert Hayes, the young American officer who photographed the disassembled Jeep in September of 1945, returned to Detroit after the war, worked for General Motors for 33 years, eventually becoming a senior engineer in the truck division. He kept a personal diary during his occupation service, now held by the U.S. Army Military History Institute. An entry from September 3, 1945, reads, "Interesting scene at the Yokosuka Arsenal today. Japanese engineers had completely torn down one of our Jeeps, every component laid out and labelled like an anatomy lesson. The chief engineer seemed almost embarrassed when I found him there, like I'd caught him stealing secrets. The funny thing is, there are no secrets. It's just a Jeep. Simple, tough, does the job. But I guess when you've been building fancy stuff that doesn't work as well, simple things can look like a secret." Hayes couldn't have known that his casual observation captured something profound, that the fancy stuff that doesn't work as well represented an entire industrial tradition and that the simple Jeep would help catalyze one of the greatest manufacturing transformations in history. He retired from General Motors in 1978, died in 1989, having witnessed Japanese automotive companies surpass American manufacturers in reliability and quality. His diary doesn't record whether he connected that transformation to the scene he witnessed in 1945. Perhaps he did. Perhaps he understood that small moments can have large consequences, that defeated nations sometimes learn lessons victors forget, that humility about one's methods is more valuable than pride in one's victories. Or perhaps he never made the connection. History is full of people who participate in important moments without recognizing their importance. By the 1990s, Japan's automotive success was undeniable and unremarkable, just the way things are. Toyota becomes the world's largest automaker. Honda and Nissan are global brands. The phrase Japanese quality becomes synonymous with reliability. Luxury brands like Lexus successfully challenge European manufacturers in their own territory. And four-wheel drive vehicles, the direct descendants of that original Jeep philosophy, are everywhere. Toyota Land Cruisers, operating in conditions that would destroy lesser vehicles. Nissan Patrols crossing deserts and jungles. Mitsubishi Pajeros winning rally championships. All embodying lessons learned from studying American simplicity in August of 1945. The irony is complete. American manufacturing, which once led the world in systematic efficiency and practical design, struggled through the 1970s and 80s with quality problems and outdated practices. Japanese manufacturing, which began by copying American methods learned from captured equipment, perfected those methods and added innovations of their own. The Toyota production system, born from Yamada's insights about efficient manufacturing, is studied worldwide. American companies send delegations to Japan to learn Japanese methods never quite, recognizing that these methods originated from American practices, observed and refined by engineers who learned from defeat. By the 2000s, globalization homogenizes many practices. American companies adopt Japanese quality control methods. Japanese companies establish factories in America, bringing their techniques with them. The distinctions blur, but the fundamental lesson remains: the willingness to learn from unexpected sources, to question assumptions, to let reality override ideology. These are the foundations of progress. Nakamura understood this in 1945. The Jeep taught him. In 2007, the Nissan Patrol celebrates its 55th anniversary. The company produces a commemorative book documenting the vehicle's history. There's a section on the original Ford W60 model from 1951, including interviews with surviving engineers who worked on the project. One interview is with Hiroshi Tanaka, now 94 years old, one of the engineers who examined the Jeep at Yokosuka in August of 1945. "What do you remember most about that assignment?" the interviewer asks. Tanaka thinks carefully. "The shock," he says finally, "the shock of discovering that our assumptions about engineering excellence were wrong. Not entirely wrong. Japanese craftsmanship has value, but wrong in the sense of incomplete. We thought quality meant precision. The Americans taught us quality means fitness for purpose. Did you realize at the time how influential that lesson would be?" No. At the time, I was just confused. Confused and somewhat humiliated. Here was this crude American vehicle that worked better than our sophisticated designs. It seemed impossible. Only later did I understand that crude and simple are not the same thing. The Jeep was simple, not crude. Elegantly simple. And the Patrol, do you see it as a descendant of the Jeep? Tanaka smiles slightly. The patrol is its own vehicle. Japanese design, Japanese engineering. But yes, the philosophy underneath design for reliability, for real-world conditions, for maintainability that comes from lessons learned in 1945, from the Jeep, from Nakamura-san's insistence that we question everything we thought we knew. He pauses, looking at photographs of the original 4W60 patrol in the commemorative book. We lost the war but won the peace. And we won the peace partly because we were willing to learn from defeat. The Jeep was one of our teachers, perhaps our best teacher. Today, the Willys Jeep is recognized as one of the most influential vehicles in automotive history. Museums worldwide display restored examples. Collectors treasure them. Military historians study their impact on World War II logistics and mobility. The design influenced post-war vehicles on every continent. But the Jeep's influence on Japanese engineering is less widely recognized. The story of Nakamura and his team disassembling a captured vehicle in the final days of the war isn't part of popular historical narrative. It's too small, too technical, too far from battlefields and famous generals. Yet this small story illuminates something important about how nations learn, how industries transform, how defeat can become the foundation for future success. Japan did not become an automotive powerhouse by perfecting pre-war methods. It succeeded by learning from enemies, by questioning tradition, by accepting that defeat revealed truths about reality that victory would have obscured. The Jeep sitting in Bay 7 of Yokosuka Naval Arsenal in August of 1945 was just a machine: steel, rubber, glass, oil. But to Takeshi Nakamura and his team, it became something more, a mirror reflecting truths they had to see, however uncomfortable those truths might be. Truths about engineering, about manufacturing, about the difference between what looks impressive and what actually works, about the danger of confusing tradition with wisdom, precision with quality, complexity with sophistication. American engineers designed the Jeep to be simple, reliable, and maintainable. They succeeded beyond their imaginings. Not only did the Jeep help win World War II, it helped transform the industry of a defeated nation, teaching lessons that would eventually revolutionize global manufacturing. That's a victory measured not in battles but in decades, not in territory conquered but in ideas transmitted, not in enemies defeated but in competitors taught. The war ended in August of 1945, but the conversation between American pragmatism and Japanese craftsmanship begun when Nakamura opened that Jeep's hood continues still. In every reliable vehicle, in every efficient factory, in every design that prioritizes what works over what looks impressive. 3 final scenes, separated by time but connected by consequence. Nakamura stares at a vehicle he doesn't yet understand, about to begin a learning experience that will reshape his understanding of engineering. The war is ending. Everything he believed about Japanese industrial superiority is about to be tested against simple American steel. Nakamura, now 62, reviews designs for the next generation patrol. A young engineer proposes a sophisticated independent suspension. Nakamura asks his standard question, but will it work when conditions are not ideal? The young engineer doesn't yet understand that this question comes from a Jeep disassembled 23 years earlier. American workers build Japanese-designed vehicles using Japanese manufacturing methods that were originally inspired by American practices observed in defeat. The circle is complete. The lessons have come home. Geography, nationality, victory, defeat. These categories matter less than the willingness to learn. The Jeep taught Japan. Japan taught the world. And somewhere in that chain of learning, the original insight persists. Design for reality, not ideology. Build what works, not what impresses. Respect the user, the maintainer, the real conditions of use. Simple lessons, devastatingly simple, just like the Jeep. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.